Hello my dear all students, welcome you all in BEAT. My name is M.SHADAB, I am your MSD Sir, and today we are going to discuss a very interesting topic, class 11, that is the rotational mechanics. Before going to start, I would like to introduce myself to all of you. As you know, my name is M.SHADAB and the students know me like MSD Sir. My nickname given by my all dear students is MSD Sir. I've been into teaching physics since last 15 years and I taught and mentored more than 1 lakh students online as well as offline. And I am a mechanical engineering graduate. Graduated in 2006 from UPTU. Since then, I've been into teaching physics in different institutes as online as well as offline. I have a keen interest to teach students and to teach how to solve a particular problem, how to troubleshoot a particular problem of physics, and how to learn the concept in very easy manner. Alright? So, without wasting your time, let me start today's topic. As you can see on the screen, today's topic is rotational mechanics, right? This is the rotational motion and this is the first lecture of the rotational motion. In this lecture, we will learn some wonderful and beautiful concept about the rotational motion, right? So let's get started. I hope all of you are here with your pen and copy. And my dear students, it is very much important to note down each and everything. Whatever I am saying here, you have to note it down in your copy. You have to make the proper and beautiful notes. If your notes are, class notes are beautiful, then you will get the interest into the subject as well as the topic as well as the chapter, right? So, this is actually a beginning of a new type of motion, because since now we have studied about the kinematics like straight line motion, motion in one dimension, motion in two dimension, as well as projectile motion, or you can say the motion in plane. In each type of the motion, in kinematics or the straight line motion, the body is moving in a particular path, maybe the curvilinear path, maybe the straight line path. You can say it is a curvilinear motion or you can say a straight line motion. But my dear friends, have you ever noticed that in this type of the motion, whether it is a straight line motion or the curvilinear motion, all the particles situated on that body moves along identical path, and this is the same path as the body center of mass, or you can say cm of that body is moving. Means all the particles of that body, including the center of mass of that body, are moving in a same path, identical path, or the similar path, right? So you can say actually the motion of the body is governed by the motion of the center of mass. I hope you all will understand the concept of that straight line motion. If the particle of a body is moving in a circle, then the center of mass of the body will also move on a circle and all the particles will move in a circle. If they are moving in a straight line, the body is moving on a straight line, the center of mass will move in a straight line and all the particles of that body will also move on a straight line. So this is actually known as, yes, this is also known as a straight line motion, or you can say that translatory motion, as you can see here, right? So we have studied all about that, or you can say kinematics of that translatory motion or translational motion. Here in this example, you can say the car is moving in a straight line. Each and everything, the tire, the point of the tire, each and every point in the car, or the passenger, the point, each and every point of the passenger is also moving on identical path. So this is known as the translational motion, but this is the chapter which is not about the translational motion. Definitely, we will solve all the problems related to that. But first we have to understand actually what is the rotational motion. So this is actually, I have told you about the translatory motion. Let me tell you something more about that, right? As you can say, the body is moving in a straight line. So each and every point of the body, including the center of the mass of that body, is moving in a straight line. Even the path of each and every particle, the linear velocity of each and every particle, the acceleration of each and every particle, right, will be same. As you can see here, at any instant of time, all of them what? All of the particles have same velocities, same acceleration, same path, same sense of motion, same sense of rotation. All are moving on the same path at any interval of time. They all follow identical trajectories. Do you know about trajectories? Trajectories are the path, right? The path followed by anybody. So each and every particle is moving on the same trajectory. This is about the translatory motion, but this is not the rotational motion. Definitely, just keep patience. Definitely, I will tell you about the rotational motion as well as the circular motion, because the chapter just about the rotational motion, right? So just concentrate here. Another thing, the kinematics of any particle of the body or its center of mass. The most important thing is that, right? The center of mass, or you can say COM, or you can say the CM, will represent kinematics of the whole body, right? As I told you, the body's motion or the motion of a body is governed by the motion of its center of mass or any of the particle. This is known as translatory motion. But here we are going to study about a new type of motion, that is the rotational motion, right? I hope you might be studied about the circular motion. This is also a different type of the motion. But before that, I would like to tell you about something rigid body, right? What is the rigid body? First we study about the rigid body. First we know about the rigid body. Then after that, after understanding the rigid body, we will just learn about the rotational motion as well as the circular motion. So just concentrate again here, and I think all of you are noting down each and every point, each and everything, whatever I am saying, you all are noting it in your copy and you are making the proper notes. Okay, it's very necessary that you have to note it down, right? So what is the rigid body? My dear students, just think about any object, any such object. If you are going to apply some deforming force on any object, so the relative distances between any of 2 points on that body, right? Just let me make it more simple for you. Suppose there is an object. Right? And we are saying that this object is actually a rigid body. We are saying that this object is actually a rigid body. We are interested to find the definition, and we are interested to find the things about the things. What are the special things about the rigid body? What special things make this body as a rigid body, right? Suppose this is a three-dimensional body of arbitrary shape, and it has any 2 points. Let's say the point A, and you can say the point B. And my dear students, the distance between them is supposed to be R1. If this point has a distance between them is R1, and if we are going to apply some forces on it, deforming forces, you are going to apply some forces. Suppose you are going to apply some force here, F, and again you are applying some force F here. Maybe another body will deform. If it is a softer body, if it is not a rigid body, if it is a soft body, it will deform, right? Suppose a sponge ball, it will deform, and the distance or the relative distance between the point A and B will change. But if it is a rigid body, on applying or deforming forces, the relative distances between any 2 points on that body will never ever change. Point to be noted. Any object or any body is said to be a rigid body if we are applying the forces or applying a force on that body. Then on applying the deforming force or forces, maybe you can apply another force, suppose F1 from here, and you can apply F2 from here. So the net force is 0. They will cancel each other, they will again cancel each other. Net force is 0 on that body. It will not move at all, it has no acceleration at all. But you are applying the deforming forces. These two forces tries to deform it, these two forces tries to deform its size and shape. But if it is a rigid body, the distance between the 2 points, you can say R1. Maybe there is another point, you can say C. Maybe there is another point, you can say D. And the distance between them is, you can say R2. The distance between them, you can say R3. The distance between them, you can say R4. If on applying the forces, these R1, R2, R3, R4, if they remains constant, my dear students, if they remains constant, right? अगर ये constants रहते हैं, change नहीं होते हैं, then this body is said to be a rigid body. I hope you all got understood, right? Suppose आपने इस body के ऊपर, इस body we have applied some deforming forces. If you apply deforming forces, then the deforming forces cannot or are not able to change these R1, R2, R3. So a rigid body is a body when on applying the deforming forces, the distance between any 2 points remains unchanged. It is known as a rigid body. I hope all of you got understood, right? So this is a rigid body. This is just the example of the rigid body. Let me tell you in a more proper way. As you can see, there is no relative motion. There is no relative separation between any two particles of the body along the line joining them on application of external forces. These external forces also can be said as, yes, obviously, deforming forces. Then this body is known as rigid body. Suppose this is a sponge ball and you are trying to just compress it. If it is compressed, then it is not known as the rigid body. This body is known as soft body or the softer body, right? So this is just the definition of the rigid body. And rigid body is said to be rigid if on applying the deforming forces, its size and shape remains constant, size and shape remains as it is, or the relative distance between any 2 points situated on that body remains unchanged, then this is known as the rigid body. I hope all of you better understand, right? So let's move to the next slide. Let's see. No real body is truly rigid. My dear students, a very important point. A very important point that no body is 100% rigid body because a small degree of deformation is always be there. If you apply some forces, a very small deformation, very small change in shape and size always be there. Later you will be know as this like a compressibility. A new word you will get to know after some time or in new chapters and other chapters, compressibility. But here no real body is actually exist because always and always when you apply some deforming forces, there is always and always some deformation, a little deformation. But if on, you can say, as a comparison of its size and shape or with respect to its size and shape or its dimension, if the compression or the amount of the deformation is small or negligible, then we can assume that particular body is a rigid body, right? So this point is very much important for all of you. You can note down in your copy as a 3-star. No real bodies are truly rigid since real bodies deform under the influence of external forces. A small deformation always be there, right? There are some examples of the rigid body. Then later we are going to study in this chapter, in the next lectures, we are going to study these type of the body and the moment of inertia about the different axes. As you can see, they have the different formula. So definitely you will understand the rigid body and its moment of inertia and what is the formula of the moment of inertia about which type of the axis. So this is just a glimpse of the rigid bodies which you are going to study in the next lecture of this chapter. We will study it later, but this all are the assumed to be a rigid body, not 100% real, but these are assumed to be a rigid bodies, right? Now, let's come to the point. As we are studying the chapter rotational motion, so we have to just define what types of the motion. I have already told you what type of the motion that we have already studied, that is a straight line motion or the translatory motion, but now we have different types of motion too, that you can say types of motion of a rigid body, how a rigid body can move. How a rigid body can move or translate on, you can say, changes its position, right? So here, first is translatory motion. As I told you already, translatory motion or the straight line motion. If a body moves in such a way that all the particles on that body moves on an identical path, point to be noted, moves on an identical path, including its center of mass, then the motion of that body is known as a straight line motion or the translatory motion. As you can see in this example, a complete wheel is moving in a translational manner. So you can see the center as well as the peripheral point, and all the points on that wheel is moving on, all are moving in a straight line. They are moving on an identical path. So this is known as the pure translational motion, as we have studied it. I am not going to much deeper in this type of the motion. Then I will tell you more about the rotational motion. So let's move on. Next one is the rotational motion. A body is said to be in rotational motion if all the particles situated, again, just concentrate here. What is the rotational motion? If a body moves in such a way that all the particles of that body are moving on a circular path, with different radius, but all the circular paths may be concentric or definitely will lie on a same straight line. All the centers of those circles must lie on a same straight line. In most of the cases, all the circles are concentric, as you can see in this example. Here are different points. Suppose one point is here, one point is here, one point is here. They all are moving in a circle. They all are moving in a circle, right? And the center of all the circle are concentric. In a similar way, here, this point is also moves in a circle. This center is at rest. It is not moving in a circle except the center, all other particles. If some particles are here, some particles are here, some particles are here, they all are moving in a circle or concentric circle, but may not be concentric. Let me tell you something more about that. Another one. Suppose this is a rigid body, and this rigid body is actually moving about this axis. This axis is supposed to be AA dash. You can say AA dash is our different axis. And if they are revolving some angular velocity, I will tell you about that omega. This is the angular velocity. I will tell you about this angular velocity later on in this chapter. Suppose here are some points, right? This point is supposed to be P1. And this P1 is rotating in that circle, and its center is here, C1. Some point is here. So this particle is supposed to be P2, and P2 is revolving like this, and its center is here. Suppose another one is P3. P3 is also revolving on a circle, and it is revolving in this circle, having a different radius, but the center is here. You can see 3, you can say C2, right? So the center of all the circle may be concentric or maybe on a same straight line. This type of motion is known as, yes, rotational motion. That's great. So nice of you guys. This is the rotational motion, right? So I hope you all got understood what is the type of the rotational motion, what is actually the rotational motion, and how we can define the rotational motion. This is the one type of this. Another one is this. And we have some more type of the motion. Let me tell you one by one. The rotational motion, and after that we have rotation about fixed axis, right? So first we have to define what is actually the axis of rotation. Axis of rotation is a line about which the whole body is revolving. Is a line about which the whole body is revolving, and if the particles on that body are moving on a circle, the line must be perpendicular to the plane of the circle. The line must be, or the axis of rotation must be perpendicular to that circle, right? And now we can define different type of motion. First is here you can say rotation about fixed axis. Then we have rotation about a moving axis. Then we have the rotation about the rotating axis. This is another type of the motion. This is also the rotational motion. So this rotational motion is one kind of rotational motion in which the axis of rotation is fixed. So this is known as the rotation. The particle is moving, all the particles or a rigid body is moving along an axis which is fixed, which is not moving, which is stationary. Here you can say the fan is moving like this. So a line passing through the center of the fan and perpendicular to the plane of the wings, right? Perpendicular to the plane of the wings. This is known as axis of rotation. This is known as axis of rotation, right? And this is fixed axis of rotation. I hope all of you got understood what is the fixed axis. And now another type of the motion, rotation about an axis which is in translatory motion. Now axis itself is in translation. Suppose you are moving in a car, you are moving in a cycle, you are moving on a bicycle. The wheel of the bicycle is revolving about its axis. But as the bike is also in translatory motion, so that axis is also in translatory motion. This is known as pure rotation. This is known as the pure translation. If we mix both of them, then what we'll get? This is rotation about an axis in translation. A body is rotating also, and the body will rotating about an axis, and that axis is also in translatory motion. So this type of motion is known as rotation about an axis in translation. And all these things I have already told you. The rotation of a body about an axis, and that axis is also maybe in translatory motion, maybe in straight line motion. As you can see here, the rolling is one of the example of this type of motion. Rolling means if you are moving in a car or if you are moving in a bicycle or cycle, the wheel of the cycle is in pure rotation about its axis, right? If that particular bicycle is at rest, if bicycle at rest, then the wheel is rotating about fixed axis. But if the bicycle is moving, then the axis is also moving, and this is known as rotation about an axis in translation. So I hope all of you got understood what is the rotation about an axis in translation. Let's move to the next one. Rotation about an axis in rotation means a body is rotating about a particular axis. A body is rotating about a particular axis, but that axis is also rotating about any another axis, as you can see the example here, right? This body is rotating about this axis, right? But this axis is also rotating about this one. As you can see, suppose this is the type of motion here. It is rotating about this. Here, this axis is rotating like this. Okay? Here you can see also the axis. This is the axis about which the axis of the body is rotating. As you can see, this is the axis. Here is the axis about which the body rotational axis is also rotating, and body is rotating about another axis. I hope you got understood, right? So this type of motion is known as rotation about an axis in rotation. So I hope all of you got understood what about the pure motion, what about the translatory motion, what about the rotational motion, and rotation about fixed axis, rotation about axis in translation, rotation about axis in rotation. So this is all about the rotational motion, how a rigid body can rotate about an axis. I hope all of you got understood. There is no problem, and all of you, I hope all of you are just noting down in your copy. You are making the proper handwritten notes. Whatever I am just showing here, whatever I am telling you, whatever I am just explaining, you all are noting it down in your copy. That's great. So nice of you all, guys. Let's move to the next, and here is kinematics of rotational motion. So we will study something about the kinematics of rotational motion in another lecture. So this lecture was all about, in this lecture, what we have studied, right? Summary of the lecture. First we studied about motion. What is the motion? Then translatory motion or straight line motion. Then we have studied about, right, what is the rotational motion. Before rotational motion, we already also studied about rigid body. What is the rigid body? How to define the rigid body? How you can define rigid body? Then we have studied about the rotational motion. Kinematics we have not studied yet. We will study about the kinematics like the angular velocity, angular displacement, and angular acceleration. Then the torque and axis of rotation. We will study in the next lecture. This lecture till here we have studied the motion and the rotational motion and types of the rotational motion also we have studied. So I hope you have enjoyed the lecture, you have understood each and everything, and you have cleared your crystal clear, right? Crystal clear concept and the study of all of the motion. So till now, this is all about this lecture. Me, M.SHADAB, your MSD Sir, now signing off. We'll meet you again in the next lecture with the kinematics of rotational motion. And in the next lecture, what we will study? We will study angular displacement, whether it is a vector or a scalar. Then we will study angular velocity, instantaneous as well as the average angular velocity. Then angular acceleration, definition of the angular acceleration, then what is the instantaneous angular acceleration and the average acceleration. So till then, bye-bye, keep smiling, keep practicing, and stay healthy, stay awesome. Bye-bye, all of you.